All right, remember we talked on Friday, you want to have a picture of what is happening in the real world. So you have this horizontal and you have this vertical. A girl throws a discus 5 feet off the ground. So then you also want to have like what's happening out in the real world. She is 5 feet off the ground and she is throwing the discus and it's at a 40-degree angle at initial velocity of 50. So that's going to go over here. 40-degree angle, initial velocity of 50. Okay, at what time does it hit the ground? What's the max height? Is this humanly possible? All right, so you can't see my calculator, but what I'm going to do is I'm going to do 50 cosine of 40, and I get 38.3. So this is 38.3. I'm going to do 50 sine of 40. And so this is 32.1. So I'm going to have x equals 38.3t and y equals negative 16t squared plus 32.1t plus 5. And it says, at what time does it hit the ground? So I'm wanting this right here. So I would need to use the quadratic formula on this equation. So again, you can't see what I'm doing, but I'm going menu. I'm going into algebra, I'm going polynomial tools, I'm finding roots, and I'm typing in my numbers. And it tells me 2.15. Now it also gives me this other answer that's back here, that's a negative 0.15. Now this is not something I need right now, I just need the 2.15. It says at what time does it hit the ground? So how far does the discus travel? I would do 38.3 times 2.15. So how far does the discus travel? I'm just going to highlight this because this was a kid's question. So you might want to put like A's, B's, and C's. So how far does it travel? I'm just going to call that A, and I'm going to say it travels 82.35 feet. And then it says at what time does it hit the ground? So then I'm going to use that quadratic formula and I'm going to say 2.15. Then it asks for its max height. So I want to use this. This right here, I don't know how high, but I know these two times. So I can do a negative 0.15 plus 2.15, hit enter and divide by 2. So it happens at, 1 second. Okay, that is not a height. That is a time. So I'm going to take that and plug it into here to answer the question, what is the max height? So I'm going to do a negative 16 times 1 squared. I don't really need the 1, I guess, plus 32.1 times 1 plus 5. And my max height is 21.1 feet. And is this humanly possible? I would think so. I've watched a lot of good discus throwers. I didn't write this question. This question was written by a student. I think it was last year, maybe 2 years ago, because somebody wrote one about Colin here. All right, so Colin attempts to throw an inbound pass from one end of the basketball court to the other. He throws the ball with a starting height. So again, that's what's happening in the real world. He's throwing the ball with a starting height of 6 feet. So this is 6 feet high. The other side of the court is 94 feet away, and it's in the air for 1.75 seconds. Says, what is the initial velocity? Okay, if you look at this, we know nothing about this triangle. But we looked at one of these on Friday. So V sub x equals, not V sub x. X equals V sub x times t. Well, I don't know V sub x, but I know that it goes 94 in 1.75. So can't I solve for V sub x and say, okay, 94 divided by 1.75. So that's 53.7. That goes right here. Okay. And then, sorry, I'm going to write that here, 53.7. And then can't I do the same thing? I'm at the ground, feet, so it's a negative 1.75 squared plus V sub y times 1.75 plus 6 because that's the starting height. I'm just going to use a yellow highlighter. This has no t in it or variable, and this has no variable. So I'm literally going to type exactly that in my calculator. 16 times 1.75 squared plus 6. I type the whole thing in. I hit enter. I get a negative 43. Oops. So I'm going to have 0 equals a negative 43 plus v sub y times 1.75. So when I add the 43 and then divide, sorry, I'm just going to do that without writing it all. So my v sub y is 24.6. 24.6. So it says, let's just read this question here. What's the initial velocity, horizontal, vertical, and the angle? Okay, well, I got 2 of them, but I know Pythagorean theorem, so I'm going to do that 53 1 squared plus the 24 1 squared, and then I'm going to square root that answer. Sorry, my calculator, it's like 10 o'clock on a Saturday night, so I can't work my calculator. So 59.07, I guess. It's fine if you rounded that. And then how do you find the angle? Well, you have 3 sides. So personally, I just always, because I know my velocity, so I always just do the inverse tangent of 24.6 because that's opposite divided by 53.7. But it really doesn't matter. So this angle in there, I got 24.6 degrees. Okay, so that's answering the velocity questions. Okay, that's going to be like this problem right here is your project, which we're going to talk about when I get back. Okay, the football player one. So if you haven't gotten these last 2 done, maybe pause and see if you can do them now. A football is kicked with an initial velocity, so you do know some stuff on the velocity triangle. You know it's kicked at 25 meters per second at 45 degrees. So I can do my whole 25 sine of 45 and 25 sine of, or cosine of 45, and you should get the same answer, 17.7. It's okay if you rounded it differently. It took 4 seconds to hit the ground, so if I write a picture of what it's doing in the real world, it's kicking off the ground to the ground, right? So it's kicked. It doesn't say that. That's why you got to be careful when you write your own question. I'm just assuming it's kicked off the ground because it's football is kicked. I guess you could have punted it. So be really careful when you write your own question, but we're going to just go with it's hitting the ground there. Okay, and so it took 4 seconds to hit out here. What's the ball's highest point? Well, wouldn't that happen at 2 seconds? Oh, sorry, I wrote T. Because if this is a 0 and this is a 4, then I really don't even need a calculator to find out it does this. So if I write my parametrics, 17.7 T, and then this was in meters, so it's going to be a negative 4.9 T squared plus 17.7 T plus 0, because we're saying it went off the ground. So if I take and put 2 in there, so negative 4.9 times 2 squared, I literally just typed 2 squared, plus 17.7 times 2. I'm going to hit enter. And so my highest is 15.8 meters. Okay, and what's the horizontal distance? Well, it covers it in 4 seconds, so 17.7 times 4. The horizontal distance would be, so the second question, I got 70.8 meters. Okay, and then it says, so hopefully if you didn't do this last one, maybe pause it and try it on your own now. Miss Dub hucks a frozen turkey off her house. She is 5 meters off the ground when she hucks the turkey. So this is 5 meters, and it lands 20 meters away, and it's in the air for 1.8 seconds. What is the horizontal and vertical velocity? You start doing these problems, and they start looking the same. So they're either going to give you stuff like the one above about the football, or they're going to give you information on the velocity triangle, but you should be able to figure it out. So I need to find the velocity, so I do the same thing. So my x equals v sub x times t. Well, v sub x is 20 meters in 1.8 seconds. So my horizontal velocity is 20 divided by 1.8. So it's 11.11. So I'm just going to put 11.1. And then I'm going to do my same thing for my y. My y equation would say y equals negative 4.9 times 1.8 squared plus v sub y times 1.8 times my starting height is 5 meters. Oh, and I'm at the ground, so at 1.8, so that's a 0. So again, I just like to type everything in on this side that doesn't have a variable. So I'm literally going to type in negative 4.9 times 1.8 squared plus 5, and then I get a negative 10.876 plus v sub y times 1.8. So I'm going to add that to the other side and then divide by 1.8. And I end up getting my v sub y is 6.04. Okay. So I throw it more out than I throw it up. And so it says, what is the horizontal and vertical velocities? And then what is the turkey's max height? Okay, well, to get the turkey's max height, you are going to have to actually officially write the parametric. So x equals 11.1 t, y equals negative 4.9 t squared, plus 6.04 t plus 5. So to get the max height, I know this time, but I don't know this negative time. Because to get the max height, you're going to have to add them together and divide by 2. So I'm going to go into my menu, algebra, polynomial tools, find roots, negative 4.9, 6.04, and 5. One of my roots is actually 1.799, which is 1.799, which is 1.8, which is good because that means I did this right. And then this negative root that's back here, I should erase this because, there we go. You can't see it then, is a negative 0.57. So I'm going to add these together. So a negative 0.57 plus 1.8, hit enter and divide by 2, and I get 6.2 or 0.62. That is not how high the turkey is. That is the time at which the turkey is at its highest. So I'm going to take that and plug that into here. So negative 4.9 times 0.62 squared plus 6.04 times 0.62 plus 5. And I'm going to type that in there. And my answer for the highest is 6.86 meters. Okay, so this should have been some good practice. And then we will take a look at things when I get back on Wednesday. We're going to, so I would get yourself what questions we need to go over because we are going to start our test on Wednesday when I get back. We're not going to do the whole thing, but we're going to get in groups and kind of start talking about that stuff. All right.